All right. Okay. So it has come to this, folks. We are here once again. Learn math with me, Brian Sapinski. Brianna is somewhere there in the background. She's just waiting to get her
bingo.
She's getting her last little bit of work fish. Oh wait, what are you bingoing? Okay, you have your stuff to do too.
Bingo
don't you?
about this. What?
I don't even know what that means, folks. But
bingo, you guessed it. More math with Brian.
Yes, well, you still have some math to do, don't you? You still got some to finish, right?
Well, I'm gonna do that with Precious.
Okay, apparently my wife is becoming a wrestling valet because now her name is Precious. Oh, we're Raids and Rowan and starting already there.
Oh, God.
Gonna miss these guys on a live basis, aren't you, after tomorrow, folks? Anyway, all right. So as I announced, this is gonna be our last regular live stream in terms of that you submit topics and and we'll do some examples of stuff live or whatever. Okay, so that's what that's what we got here. I'm just establishing the live chat there on the side, so please, by all means, come in. But I just want to make a note remember, tomorrow is our official finale. And
I'll just stay home and help you.
Yes, okay. And for tomorrow's live stream is going to be for our finale. It's going to be an all fun and games show, whatever. We're going to revisit all of the games that we played during these past several weeks or whatever. I encourage you guys to come by, tell your friends, and please interact and play with us. So this way it's not just us playing. We want to play with you guys and against you guys, and so that you guys have a chance to see and with everything it is that we're up to. But in the meantime, right now, let's get some math topics done. Throw your topics in and whatever suggestions you like, and we'll get some things moving here. And let me see. I'm trying to think of some of the stuff that we're doing. I'm doing recently here. Just as some examples, but please, by all means, throw a suggestion out there in the chat and let me know what it is you'd like to see me do. So I'm not fishing on this last day for too many topics here, because I enjoyed a lot of the suggestions that I was giving on the Algebra 2 level, and but like I said, anything on the K-12 spectrum, please, by all means, I want to see all the stuff that it is you guys have and want to offer and stuff like that. Okay. Oh, here, Joey, I got a question for you.
Okay.
You can actually.
Okay, holy diamond mine card.
You can actually help me with something. Okay. All right. Here, answer this question for me. Okay. When you flip a coin, all right, what possibilities can come up on the coin?
Heads or tails.
Okay. So if you flip a coin, wait, come back here. Wait a minute. Wait. Listen to what I'm saying. Okay. So if you flip one coin, okay, if you flip one coin, then that means that you have a possibility of a heads or a tails. Okay.
I would choose heads.
Okay. Wait. It's not a matter of what you're choosing. Wait. Stay here. Okay. All right. Now, let me ask you this. Okay. Now, what happens if you flip two coins? Okay. What can come up on the two coins? What's one possibility? What's one possibility of what could come up on the two coins? Well, okay, wait. So let's list it out. So what can come up on the first coin?
Heads.
And the second coin?
Tails.
Well, let's. Okay, all right. All right. Heads on the first one, tails on the second one is a possibility.
Heads and
all right, Joey, what else can come up?
Heads and heads.
Heads and heads. Oh, wait, let Joey get these. Okay, what else can come up on the two coins?
Tails and tails.
Tails and tails, and?
Tails and heads.
Tails and heads. Okay. And then what about if you flip 3 coins.
Oh gosh.
Okay, Brianna's jumping in here.
He
sort of got the idea, but I get as soon as we got to 2, it's a little beyond him.
Heads, tails.
Well, here, let's start easy. Let's make them all the same first. Okay.
Tails.
Sure.
Oh gosh. So does that mean there's 9 of them?
Wait. Let's find out. Hold on a second.
Heads, tails.
Okay, so you got 2 heads and a tail. Here, rearrange that a little bit.
Huh?
Rearrange this. Rearrange heads, tails.
Tails, heads.
Okay, and I think there's another way.
Heads, tails, heads.
Sure.
You could have tails.
Oh, we already
tails, heads.
Okay, now you got 2 tails and a head. Start rearranging them.
Tails, heads.
No, you got.
I'm sorry. Tails, heads, tails.
Hands. There's another combination of 2 tails and a head. You guys see it out there? You want 2 tails and a head. Where's the only place the head hasn't been yet? At the beginning.
Is that it?
Okay, turns out that it is. Okay, so in each of these different events, everything that we've listed in the brackets are all the possibilities by which each event can ultimately play out and stuff like that. So these are all examples of what you call within the world of probability and statistics. These are what are called sample spaces. Okay, so this tells you every single possibility in which that could play out. Now, depending on how you want to describe the sample space, they could be cases like these where all the possibilities have an equal opportunity of coming up. Could also phrase them a little bit of a different way, where the sample spaces may show stuff where the different things in the space don't come up equally. Because, like, for instance, I could say with flipping 3 coins, okay, this sample space represents the possible list of the flips, okay. But what if for the same event? What if I wanted to do a sample space for the number of times heads comes up? Let's see how this sample space would read. Okay, so as you look at those possibilities, Brianna, how many? What are the different possibilities in flipping 3 coins for the number of heads that could show up?
Do I count all the heads?
Well, on each individual one, on each individual group, not all together.
1.
Okay, there are some scenarios where it shows up where there's 1 head.
And then twice.
There's some where it shows up twice. There's others.
And then 3 times.
There's one where it shows up 3 times.
Yeah.
There's another.
Huh?
There's another possibility.
Huh?
There's one outcome you haven't looked at. You guys see it?
Oh, no heads.
Where no heads, right? The 3 tails. Okay, so this would be a sample space that goes according to this criteria for the same event. And now the thing is that when you look at these and you look at the individual list of flips, each exact outcome, you can see that some of these show up more often than other ones. Like, so in general, we see that there are 8 outcomes here, and I'll re-explain the 8 in a second because we have talked about it before. But as you look at these, how many times out of the 8 possibilities do no heads come up? How many times do you see no heads?
1.
Okay, just the once. Where's all that? So there's 1 out of 8 times. How many times out of the 8 does 1 head show up? Look again. I see something different.
Oh, 3.
3 times, right here, here, and here. So there's 3 out of those. How many times do 2 heads show up?
3.
3 times. And how many times do all 3 heads
Once.
show up? Once. Once out of 8. So here, wait. Come back. So here's my question then. So we demonstrated sample spaces.
Yeah.
Now, the reason real quick why there were 8 outcomes available to that one. Each time you flip a coin, each time you flip a coin, how many possibilities can show up on each coin?
2.
2 outcomes on the first flip, 2 outcomes on the second flip, 2 outcomes on the third flip. How do 3 twos calculate to 8?
What are you trying to do?
Joey, come on. How do 3 twos calculate? Joey, you multiply 2 times 2 times 2, and that's what gives you
and you do 2
the 8.
times 2 for this too.
There were 4 outcomes here, the same as 2 times 2, and this was just one single.
Joey was
One
trying to make me
experiment with
show
2,
the
2.
flamingo on my hoodie.
So okay, just chill. Okay, I got it. But that's how the 8 count. Now this was the example again of when we did the counting principle some time ago. We did this where you have a multi-stage event where you come up with the number of possibilities of performing each event and you multiply it together to get the total number of things. And then all these fractions that we came up with. Brianne, 1 out of 8, 3 out of 8, 3 out of 8. What are these called when it's the chance of an event taking place? Starts with a P. Do you remember?
Percent.
No. You could turn them into a percentage, but the word.
Possibility. Oh, probability.
Yeah, it's the probability. Yeah. So that's what all of these are. This is the probability of flipping 0 heads. This is the probability of flipping 1 head, of 2 heads, and of fix that. Probability of 3 heads. Okay. So that's what all those come from. I wanted to ultimately get to that because my discrete guys are getting, because this probability stuff, which we talked about in past live streams, whatever. This is probably my favorite category in all of discrete and statistics and stuff like that. I love, as you've seen with some of the games that we do. I love all these types of games with the that involve chance and probability and all that kind of stuff. So let's see. So based on that, what if I challenge you guys out there, to test a couple of these things and see what stuff you ends up with. So what if I asked you for building off these probabilities? What if I wanted the probability of, let's say, of getting at least 1 head? What would that be? What would the probability? Okay, wait, Grant. Okay, wait. What would the probability be of less than two heads? And
4.
Okay, wait.
4.
Out of
8.
Okay, the 1 where you roll none and the 3 where you roll 1, so that would be 4 out of 8, which reduces to. Was there 4 out of 8? Okay, so it's a 50-50 shot of rolling less 2 heads. How about the probability of rolling at least 1 head?
7 out of 8.
Okay. And the probability of not rolling 3 heads.
7 out of 8.
Again, yeah. Look at all the others. Yeah. So 7 out of 8. Yeah. You just
some
remove
quarters,
the 1,
so,
okay?
yeah.
And other things can happen from there and stuff. So to try to be able to get all those things put in place. So you get into the simple probabilities of those things or whatever. And so we've talked about those in some cases. Oh, hello! I see somebody else has popped in. Hello there, viewer. Please say hi in the chat. I want to hear what topics you want us to do here while I'm fishing with some probability stuff and other things with sample spaces and having fun.
Since technically
and all
this would
business.
count, I guess, as our Fun Friday live stream.
No, wait, no. Our Fun Friday is tomorrow. Remember, we're playing all the games tomorrow.
We could still play a game where I have like 3 quarters here, and we could see which one of these it would be.
Mm-hmm.
And we could see which one of these will be. And
well, here there is. Well, here, wait. Okay, wait. Hold on a second. Here, do me a favor. Get a 4th quarter for a second, because there is something else we could demonstrate or whatever. Something I want you to see. I want you guys to see this out there too, because since I'm not at this immediate time, I'm not going to have as much of an opportunity to do it anymore. But I want to show this out there. Okay, I'm asking Brianna. She grabbed 3 quarters, but I'm asking her to grab a 4th one, because here's what I want her to and you guys to see. So if we flip 4 coins, playing off of this possibility. Hello there, out there, world. Okay, so when you flip 4 coins, we know that the possibilities in terms of the sample space are that you could flip 0, 1, 2, 3, or 4 heads, and of course tails would be the same likelihood and stuff like that. Now, as far as how it looks, okay, we recognize then that, okay, there's only one way out of, well, first, let's see the possibilities. So wait, multiply 4 twos, so 16. We know, okay, so we know that there's 16 different ways we could play. Now we know there's only one way out of the 16 that no heads show up. There's 1 out of 16 ways that 4 show up. Now let's get all the ones in between. Now, for the 1 and the 3, okay.
It's the same.
Well, okay, we know they're going to be the same, but like, how many ways can either 1 head or 3 heads show up? Think this way. How many coins are there?
4.
Okay, because then think this way. So it's going to be 4 on each one. If you're not sure, notice it. Here, with 1 head. The 1 head could be on the first coin. It could be on the second. It could be on the third. Or it could be on the 4th. So you see like that? And I could reverse all these heads and tails, and I'd have all the 3 possibilities.
So does that mean the 2 would be half?
Not necessarily. Well, here, wait. Remember, there's got to be 16 total possibilities. Add up the 1, 4, 4, and 1. How many does that give you? Add up 1, 4, 4, and 1.
1, 4, 4.
And 1. Add those up, you get
9.
Check it again. 1, 4, 4, and 1.
Wait.
Forgot the 1.
No.
1 and 4 make.
Oh, wait. Oh, I thought you were talking about these numbers.
No. This 1,
5.
this 4, this 4, and this 1.
So 5.
5 and 5 is
10.
How much is left out of the 16?
6.
6. So it's 6 out of 16.
Oh.
Okay. So you see that obviously flipping 2 is the most likely thing. Now here's the thing that I want you to see. And I want you guys to see this out there too, because this is in my discrete math course.
Dad,
in terms of probability and statistics. Okay.
3
So all right. Okay. Here's what I want to do. Okay. I'm gonna wait. Hold on a second. Okay, I'm just trying to do something there. Okay.
Something else we could do. We could shake up the quarters.
Now, right this second.
Put them in our hand.
Okay, all right. So, okay, so what did you do the first time? What did you get?
Okay.
What'd you get the first time? How many?
I'm rolling them like dice.
How many heads did you get the first time?
Probably not a good idea.
Wait, how many heads did you get the first time? I forget.
1.
You got 1.
I think I got 1.
Okay. So we got that. Okay, cool. Thank you. Okay. All right, so you got one head the first time. Okay, now
And then 3
let's.
tails.
Okay, we know that. If you got one head, you got 3 tails. What are you doing?
I dropped the quarter.
Okay, bring it over here. Okay, so watch what we're gonna do. So we marked that. We're gonna keep on marking these. We're gonna do this a bunch of times here. Okay, and the thing is that there's going to be sort of a long-term trends that I want you guys to notice as we don't physically try to flip them. It's gonna take forever. Okay, we're gonna be here all hour just doing this one problem, and I don't want to do that.
So can I just,
Not on the
like,
last day.
can I do it like?
Submit something, please.
Can I do it like a dice roll, kind of?
Sure, that's fine. That doesn't quite work. Here, give me 2 and you take 2. Okay, so you have a chance to shuffle.
3 heads.
Okay, wait. Hey, wait. Leave some space with you. Okay, don't have to flip it over on your hands either. Okay, stop.
I'd like to.
Okay, how many heads you got?
2.
2. You don't have 2 heads. Those are tails.
Oh.
I have 2 heads. Okay, so we got 2 total. All right, Joe, let go of my arm.
I need you.
No, not right now. I'm live. I'm live right now. Okay, go. Okay, I got 1. You got 2. Okay, so that's 3. Okay, all right. Okay, now as we go along with this, guys, watch. Okay, none. 1. Okay, all right. Now, as we go along with this, you're going to start to notice a trend as we work our way along here. Okay, so we got 2. Go. 1.
None.
Okay. So far, the trend that I'm looking for is not happening. None.
1.
1.
Oh no.
No. Wait. Hold on a second. It's not what you think. I mean, the data right now. Okay. 1.
None.
You're not giving your hands enough space. You got to really ball it and shake. 1.
None.
This is not the way it's kind of supposed to go here.
Joey, I swear, if he started dropping coins.
Stop throwing things.
2.
And I got 2. Okay, so we got a 4. Stop.
If
Enough.
you're gonna throw anything, just throw a bunch of rubber ducks.
No throwing.
Okay. Rubber ducky.
He's making a fuss because he wants to switch right now, and I don't have any, and I'm not in a position to give it. Okay.
What's happening? Okay.
2.
9. Oh no! What I say?
Okay.
Throw
All right.
the rubber ducky.
Stop, guys. Enough. Joey, stop. All right. Can you reach up there and get the thing here? All right. Okay. Hey, here's the point I was trying to make here because it's getting a
little out of hand.
Well, okay. The data as it's showing it right now, and like if I continue this and we keep on checking the outcomes here, okay. So as we keep on checking things, what you're going to see is that eventually. Wait, hang on a second. Here, wait. Don't worry about the flip. I got it covered. Okay, I'm just checking on both ends for myself. Okay, so I mean, like, okay, so we did let's see. The experiment is done here, and okay, all right. So here, after 16 trials to fit 16 outcomes. Okay, this is what we got at the moment. Now, it looks as if, like, even though in spite of our probabilities, we got one to happen a lot more often than the other things. So it looked imbalanced. But here's the eventual hook. Given the way these probabilities go, I mean, everything we did here suggested that we got 1 out of 16 there. We got 7 out of 16 here, 5 here, 2 here, and 1 here. All of these, based on our doing the 16 trials and stuff like that, these are an example of what are called experimental probability. Because this is what it is that we got from actually performing the trial the required number of times and seeing how it came out. Whereas what these are supposed to come out to is what is called, Joey, we're going to get in trouble. is what is called theoretical probability. This is what is supposed to happen after you perform an event an infinite number of times. This is where the chances are supposed to trend to. Okay, so the thing is that like even though our experimental didn't line up with this exactly, sometimes it will, sometimes it won't. The whole idea is we just did 16 trials. If we did, let's say, 160 trials or whatever, then what might happen is over time, some of these stacks will get progressively higher, and some, by a faster rate, and some will not rise as much. And eventually, at some point or another, like after you do this 160 times, 1,600 times, 16,000 times, or whatever the case is, eventually the curve will ultimately start to try to even itself out and get closer and closer to looking the way the frequencies of the theoretical probability are supposed to. Okay, so you have to think of this as the experimental probability. You have to look at, okay, what's happening right now, but the theoretical probability is if you continue to perform the experiment to infinity, where do you expect everything to ultimately land? That's the way it is that sort of thing, looks and stuff like that. So the fact that we got 7 out of 16 to have only 1 out of the 4 coins show up, okay, that was luck of the draw that happened to work in our favor. Yeah, if you do the experiment, yours may come out different. So that's the whole nature of the situation. So I wanted to show that a little bit at the same time, just to get some stuff out there. And there's even some other conversations that we can have about all those kind of things. But another day, another time, and stuff like that, perhaps. Okay, fate will eventually decide for us there. Okay, so all right, so we had some probability fun and stuff like that. So okay, what were you doing in your math today?
It was the mid chapter.
Okay, so that's right. You were just starting to get the. Okay, so you didn't do anything new since Tuesday. You were still doing your stuff with the. Okay, you were doing the adding decimals, but I know subtraction is coming up for you. So here, wait.
I think we did it.
Okay, well here, show. Let's here. Give me. Dispense some subtraction knowledge on me and stuff like that. What if I give you? Okay, set it up and go. See how you do with this one, folks. Yes, thank you.
Another quarter.
Yeah, I know you. I know you did. Yes.
I was trying. I took the quarter.
I know what you did. Yes.
Wow, my handwriting actually looking good today. Wow. And you basically do the same thing as normal subtraction, except with decimals. See? Look.
Okay, so you got that, however. Okay, now playing off of that, because you're right on that. Okay, now let me.
Oh no.
Okay, let me.
Got it on my leg.
Let me change this up a little bit. Okay, so erase that. 2.63. She's right on that.
Oh.
Okay, lines up the decimal places and do that. Okay. All right. So now, what about if you had this? Let's suppose you had. Let's say.
That book.
Okay, set up that one.
I remember that.
Well, make sure she sets these up the proper way.
I remember that.
Remember what we talked about?
I remember that, like, some kids used to, like, break these.
How?
Since it's styrofoam, like, I think, like, one person
Oh, okay. All right. Okay. All right. Well, don't do that. We just got those.
Yeah, no, I'm not gonna do that.
We just got those as we were replenishing our markers.
Yeah, and like once there's like this big gap
do
in
that.
it, there's like this big gap in it, and it was just like, oh, stop breaking them. This.
Okay.
Like this.
Okay, now just to ensure that that's the way it's supposed to go. Wherever we talked about lining up the decimal points, lining up place values. Do what you did with Do what you did with the addition. Fix that 4.5 a little bit. What can we do to make sure that 4.5 properly lines up place value for place value?
You could also add a 0 to it at the end. Okay.
Yeah, do that. Yeah. So this way you could properly see the same. Well, put it there. Put it there. I want to see that there for a reason. Yeah. Put the 0 in there so you can make sure you see the same number of digits to the right of the decimal. And then this way you recognize ones to ones, tenths to tenths, hundredths to hundredths, and seeing that. And since you started with a 2 and there was nothing here underneath, 2 minus 0 gives you 2. But how about with this? So playing off of what she
it.
So playing
I
off
got it right.
So playing off of what she did just there. Oh yes, and always checking by going the other way and seeing if it's the same thing. So, but what if then you had to deal with this? Consider this problem, Brianna. What about set that one up now? Sorry.
Yeah.
So thinking about place value and lining stuff up or whatever. Okay. See what you have to do here. Okay, you see how she did that same thing with the 0 there, and here it really becomes necessary because you notice that without that 0 there. Okay, yeah, a lot of people will, without putting that 0, a lot of people will make the instinctual mistake. Oh, there's only a 4 there, so just bring the 4 down. Nope, can't do that. So yes, so you have to do the borrow and do all that bit. Okay, so there's 11 there. So it's essentially the akin to a 40 minus a 34, which you got the 06. And yep, everything is right there the way it should, 5.506. That's exactly how you want to check it. So always make sure place value is there. Make sure that every digit in one decimal has a digit in the other decimal to compare it to. If one's shorter than the other, throw in the extra zeros. Line them up perfectly. Just in the grand scheme of things, it's just the easiest thing to do. Okay, it just make your life easy. Make sure you see the same number of digits to the right of the decimal in both, so you can line them up properly. Know what adds with what subtracts with what, and just go through it. And it'll make your life a lot simpler. And then you don't have to be intimidated by decimals anymore because then you could just, like, in terms of adding and subtracting the digits, it's the same as adding and subtracting any other regular integers or whole numbers or whatever you want to call them. So that's pretty much how it all is there and stuff like that. So everything you want to see there is good. Okay. So I'm trying to. So that's how that looks and things like that. So we got those there. Okay, what are? Okay, trying to think of some other stuff here while waiting for some submissions, ideas, or okay. Wait, where'd the eraser go? Okay.
I thought I gave you it's right there.
Oh, I'm sorry. Okay. Okay. I want to do this since this is the last day that we're doing stuff here or whatever. I want to show this for my geometry guys, because this is something that this is stuff like they're gonna see, like, you know.
Well, that's a big book.
Yes, this is stuff that they're gonna see like next week and the week after, and things like that or whatever. So I want them to see this stuff or whatever.
Trying to draw it, but it's
Okay.
kind of hard.
So what are you doing?
Book. Book.
Oh.
Big book. Does it look like a book? Pages. That doesn't look like a book.
Looks like a collagen injection gone bad.
What? No, this is a book.
So.
Dang it.
Oh, show
Once I say that, I immediately messed it up.
All right. All right. I got a little bit of a visual challenge for you here. Okay. All right. All right. Here's a circle. Okay.
It's a circle.
Draw a line, Brianna. Draw a line for me that touches this circle in exactly one place. No. Okay. First of all, that's a line segment. Line has to run forever. And see now, all right, but now you see you already blew it because now it touches the circle in two places. Draw me a line that touches the circle in only one place. No, because then when that goes through forever, it's going to pass here. So that doesn't work either. The line can only touch the circle in one place.
You can't do that.
Oh, sure you can.
You can?
Okay, first of all, establish your point, okay? And then here's the line that you can do. Ignore artistic imperfection.
Oh, on the top.
Okay, but understand, you just as easy put the point anywhere you want, and you just make sure that the line isn't tilted, that it's going to go through the interior of the circle. Okay. All right. So that's what you got here. So this is an example. I'm just going to extend a little bit because I have a little bit of an extra visual challenge here. This line that touches the circle in only one place is an example of, is an example of what is called a tangent line. Now it's not quite the same as when we were in Sokotoa lands for a long time. It's not the same thing okay, no, wait, it's not the same thing. Not the same thing. Okay. The name is borrowed from that trigonometric worlds and stuff like that, but it's not the same thing. Joe. Okay. Now, and understand, you can draw a tangent line through anywhere you want here. Now, now let me extend the concept a little bit. Suppose on the same line, okay, here's another circle. Okay, here's another circle that same line is tangent to. You got it? You see it? Okay. There are more lines that you could draw, Brianna. There are more lines that I could draw that would be tangent to both circles. So you see how this line across the top is a tangent of both circles because it touches both circles in one place. There are other lines that we could draw that are tangent to that same, that are both, that are tangent to both ones. No, wait, no, hold on. You gotta, no, that's not a line.
Yes, it is.
No, you can't change direction when you make a line.
Oh, yeah.
Okay, wait. Look at these two. Hold on. Look at these two that I have. Where can I draw?
No.
Come on.
That's the guy who always says the Sokotoa.
All right, come on. I know. Okay, wait. Look elsewhere around the figure. Where else could I draw a line like this one that will touch each circle in one place? Okay, sort of along the bottom. It would kind of be like, it would Now it's going to kind of be like this. Okay, again, ignore artistic imperfection, folks. Got the right idea there.
And that's it.
Okay.
If you try to do one of the sides, you won't be able to touch it.
So you can see it touches here and touches there. Okay, well, actually, there are others. Would you believe that there are 2 other tangent lines you could draw here?
No.
There are.
What?
You went across the top, you went across the bottoms of the circles. Tops and bottoms in theory to try to get those in place. But what about? But hold on. But here you went across the top of both of them. Here you went across the bottom of both of them. What other angles can you try to attack this from?
The side?
Well, not the sides here, because here you're only going to touch one. Here you're only going to touch one. You're not going to touch them both. Right. You try to make a diagonal cut. Okay, you got the exact right idea there. Here, let's just refine.
And you just make an X.
So with these 2 circles, how many total tangent lines are you able to make? Because you said you make an X. Because you go this way too. So how many tangent lines did we make?
4.
You were able to make 4 tangent lines between these 2 circles when they were disconnected like that. Okay, so keep this in mind what you just did. And you guys see it out there too. Okay, ready for this? Now, I'm going to change this up a little bit. I'm going to move this circle over a little bit. And we're going to see that depending on how I move this over, the number of tangent lines you could draw is going to change. Okay, because notice now. Here, you had 2 totally disconnected circles, and you were able to make 4 tangent lines. Okay? Now, what if instead of these 2 circles being totally disconnected, what if they came into contact with each other? Like, what about if the 2 circles were like this? Now try to draw.
Then there's only 2.
Wait. Now try to draw tangent lines that touch both circles in one place.
Across.
Okay. Okay. Well, all right. Well, you guys know what she's trying to do.
Across the bottom.
There is still more.
The X's?
No, you can't do an X on this one. Remember, the goal is for the line to touch each circle in one place. Right now, what do you notice about the 2 circles? They touch right down the middle. Good job there. I like it. Excellent. Yes. Okay. Perfect. All right. So how many? So
wait.
Okay.
I know.
So we established that when you have
this.
circles that look like this,
you could make a Squidward. That's his nose.
No, that's not
and
face.
then that's his mouth. It's Squidward. Oh, Squidward. Oh, Squidward on a chair.
Okay, so how many tangent lines were you able to make? How many tangent lines did we make on this one?
3.
Hey, Scott, good to see you.
3.
All right, so you were able to make 3 tangent lines on this one.
All I see is
Okay,
just Squidward.
All right, let's change it again.
Wait, I need
Wait
to
a minute.
Squidward. That's a really bad Squidward.
Grunkle Stan.
Oh, yeah. But it is, oh, yeah.
Wrong network.
It's supposed to be Squidward.
All right, okay. All right, so let's take a look. So when the 2 circles were totally disconnected, you were able to make 4 tangent lines. When they touched each other, border to border, you had 3. Okay, now what about if they intersect kind of Venn diagramming?
Ooh.
What if they interlock with each other? Now how many tangent lines can you make?
2.
Where, show me.
On the top and on the bottom.
Yes. Okay. Yeah. You can't attempt to go. You can't go through the middle on this one because in going through the middle, you're going to guarantee to hit one of the circles in 2 places. So this one you're able to make 2 tangents.
Really?
Yeah. You're only able to draw 2 tangent lines. That's it. Yeah. There's no other way to hit them both in one thing. Wait.
I can make it into Elmo.
Wait.
It's Elmo.
Stop. Wait. Okay. Now, what about this? Now, what about if Now let's say that one circle's completely.
You can only have one.
Where is it? Right there. Yes. Okay. Yeah. Again, just like say, ignore the imperfection. Yeah. Again, it's kind of like where they touched on the outsides. If they're only touching in one place, and that one line hits them both in that spot. But now, where it's only one, where one is completely inside the other, now that one place where both circles link is the only place where it goes. Because
So
again,
the closer they are, the less tangent lines you can have.
yes. So
What if it's like change your eraser set?
Because there's one other possibility. What do you think the last possibility
you
is?
go like,
But why don't you put it over here?
and then you
Draw it over here. Wait, understand. If the two circles are totally apart from each other, you're back to this.
Oh.
Doesn't matter how far apart they are. If they're completely disconnected, you can get 4. But what's the only thing I haven't drawn here? Do you see it, Scott?
In the middle.
Okay. Look at this.
You have 0 tangent lines.
Because is there any way to draw a line that touches both circles in exactly one spot? You can't do it because, yeah, even if you try to do this, yeah, you hit this one in one place, but you hit that one in 2. That's not a tangent line. If you do this one, you hit this one in one place, but you don't hit this one at all. So that don't work either. And there's no other way to make it work. So if one is completely inside the other and they have no contact, no tangents. So
circle, Cookie Monster. It's Cookie Monster. He's eating a cookie. This is supposed to be a cookie, I swear.
You need your work on drawing your Muppets. Yeah, even he says no.
So that was for the thing, to put the thing. That wasn't for the Cookie Monster. It was for this.
Chill out.
No, it's because I.
So from a visual experiment, first keep those things in mind for yourself. There. Okay. All right. Now here's where I want to go through. Okay. So here's now what I want you to take a look at. Okay. Now that was the one thing with the tangents. Now one extra thing then. So those were lines that hit in one place. When a line passes through a circle, kind of like a chord does, we talked about a chord that touches a circle in 2 places. When you have a full line that does that, that's an example of what is called a secant. That's the name of it. That's another one that comes from the trig family, from the SOHCAHTOA worlds or whatever. It's a flip. It's a reciprocal of the cosine or whatever. Yeah, pretty much. I know what you're saying.
Oh yeah.
All right. Now, with that secant, here's what I want. Okay. Chill. With that secant, here's what I want you to see. Okay. Actually, let me talk about the tangents first. I want you to see something. Okay. Here's a single circle. You remember we were talking about inscribed angles the other day? Okay, where we said an inscribed angle is half of the angle that it captures here. Okay, I want you to take a look at this. Okay, here for a single circle, I've drawn 2 tangent lines. Okay, with that so far, right? Okay, now within those 2 tangents, you can see I've captured 2 arcs. I've got this one right here, and I've got. Give me the other marker.
Which marker?
Just any other color other than what I'm using.
Green.
And I've got this one over here. Got that so far? Okay, now, between the first thing I want you to see, Brett, wait, look at, no, we're fine. Between those 2 arcs, okay, do you notice how those 2 arcs make up the whole circle? Okay, and we've talked about before here recently, we've said that the entire circle measures how many degrees?
360.
360 degrees, so you got that. Okay, so then, Brianna, get back up here. Come on, stay within. Look at what's going on. So let's suppose then, if this arc on the inside, let's suppose that this minor arc that's closer to our angle. Okay, if this arc was 100 degrees, let's say, how many how many degrees does that make the big arc on the outside, the major one? So this one from here to here is 100. From here to here is 100. How much is the big one?
260.
Got it. Yes, 260 degrees. So you got that. Okay. Now, when we talked about the okay, good. And Scott's got it too. Okay, so here's the thing. When we talked about the inscribes the other day, you remember how we were dealing with, we said it was half of the arc that it captures. The problem is that this captures two different arcs. So the question is, how do you get the measurement of this x right here? It's still going to, here's the calculation. It's still going to involve a 1/2 or half of this. The rule is that when the angle point is outside of the circle, like it is right here, the rule is that you have to take half of the difference between the major and the minor. So subtract these two from each other, Brianna. So subtract the 260 and the 100.
160.
And then get me half of that, and that gives you the measurement of that angle. What's half of 160?
80.
80. So that means that this angle measures 80 degrees. Okay. So here, just to try it again for a second. Okay. So try this one. What if the inside arc measured, let's say, 50 degrees? That means the major would be how much?
310.
310. Okay. So let's do it again. Okay. So 310 here, 50 here. Get the difference, and then take half. Scott's playing along there. See?
260.
Half.
130.
So the angle is 130. Okay. Now let me shift it up for you a little bit. Okay. What if I give you the angle and one of the arcs? Then you got to come up with the missing arc. Okay. What if I give you? Okay. Okay. Well, actually, okay. I should try to re-stress something here. Okay. Because yeah, that's true. If I give you one, you're going to know what the other one is. Okay. So there's kind of no fun in that, but it does lend to some possibilities and things like. Actually, no, wait. Actually, no, it's true. Hold on, I take that back. We can get away with this. All right. So let's suppose this. What if I told you that this angle here was 40 degrees? Okay.
The other one would be.
Okay, wait. So hold on. Let's follow this here.
320.
Okay. No. If the angle was 40 degrees.
Oh.
So if the angle at the end was 40 degrees. All right. So how much is the difference between the two?
80.
The difference between the two would be 80. Now, the thing is, I have to come up with a pair of angles that, so this is kind of like a system of equations here. I have to come up with a pair of angles that add up to 360. You with me so far, Brianna? But when I subtract them, I only get 80. To avoid the trial and error, here's what you do. We're going to take those two equations. So something and something gives you 360.
160. Is that half? Wait. Wait.
Okay, wait. There's something you could do with that one. Okay, I know where you're getting the 160. You're thinking 320 to go with this. You could. Okay, follow. Actually, you know what? Well, here, I'll show it two different ways. Let me show it my way, and then I'll show what, according to your logic, you're going to see you're going to get the same answers for the two angles. Watch this. Here, algebraically, you see it as a system of equations. Add everything up together that you see, Brianna. Okay, so x and x, that's how many x's?
Yep.
2 x's. A plus y and a minus y, what happens to those? If you add something and then you take away that something, you're left with Nothing. So those are gone. Add up the 360 and the 80. Okay, 440 equals 2x. Divide by 2 now, and you get x. This is going to be the major one. So the major is 220. So 220 minus what will give you 180?
8. You said 180.
No, it has to get 8. 280 minus what will give you 80? If you want to subtract those, then you'll get the leftover. What do you? 220 minus 80. Get it? You got it, right, Scott? 220 minus 80.
Oh,
Lost sight of what we were doing for a second. It's okay. 140. There it is. Okay. So there's that. So these are the measurements of the two. So the minor is 140. The major is 220. Now, so that's one way you can look at. Now here's another way you could get it, Brianna. Here's another way you could get it.
through my way?
Well, okay. Well, and actually, while we were finishing the answer to this question, the way you were thinking actually would not quite work. Whatever the case is. Okay. No, you have to minus some, Scott, not add. Okay. Here's the other way you could look at it. Okay. The 40 that you've got there. All right.
Yeah.
What's half of a circle? How much? What's half of a circle? Okay. So half of a circle, you got 180 and 180. If the angle itself is 40, what you can do with this is take that 140 to, how can you use the 40 on the 180s to get to 220 and 140? Oh, good to hear, Scott. Okay. So wait, how can the 40 be used on the 180s to get 220 and 140? No, wait. How do 180 and 40 get you 220? How do 180 and 40 get you 140? Wait, 180 times 40 gives you 220? You have to add them. Okay. So the thing is, if you add 40 to one of them, you get the 220. How do you get 140 from 180?
What?
180 plus 40 is 140? You just got 220 that way.
Wait,
Come on.
Subtract?
Yes.
Oh, yeah, that makes sense.
Okay. Just got caught in the moment there. Okay. But you see how it is. Yeah. You have to take the measure of the angle and you give the difference to the other. Okay. So that's how you get those. Now, here's the thing. What we just saw here, this whole formula of half times major minus minor, that's going to happen when you're trying with any two arcs that are captured by an outside angle. So it could be for two tangents like this, but it could also be when you bring secants into the mix as well. So the same rule would apply if you had a circle set up like this. Take a look. If you have, let's say, a tangent and a secant like this. So here's a tangent, here's a secant. Here's the x angle right there. Now, here are the two arcs that you capture. Here's arc number 1 right there. Okay. And then here's the big one right there. So you got that. So the same rule applies because this point is outside the circle. Because this angle points outside the circle, you have to you have to take half the difference of those. So if this arc, let's say, is 55 degrees, and this arc right here is 145 degrees, okay, set it up. Set it up, Maria. So we would subtract, and what would happen?
We would get
145 minus 55 would get us no, bigger than that.
85.
Wait, hold on. 5 minus 5.
0.
Okay. 14 minus 5.
9.
Okay, so all right, and then half of 90 is how much?
45.
Okay, 45 there. Okay, so that's the kind of thing you get out of that. All right. Okay, now this one's the kind of problem that if I gave you the angle of one of the arcs, you could try to get the other one. So it's a little simpler. So what if I gave you this, Bria? Okay, what if the angle in here is only 20 degrees, and let's say at the inside arc is 30. So I want to know what this is. Okay, so now let's go backwards, Brianna. So take a look. So here's the 20. That's the end. So what's this? So if the angle's 20, go backward. What does this have to be? How much? No, go back. You gotta go backwards. Wait, and you take away
40.
40. Okay, now here's the thing. Take a look. Is the 30 here? Is that the major or the minor in this setup? Is it say it?
Minor.
It's the minor because it's the smaller one. It's the one closer to. So that means it goes second. So x minus 30 has to equal 40.
70.
So that's 70. We got it. That's it. Right there. Boom. That's it. So that's how you play that out. Okay. So now I just want to show a couple of last examples here, whatever, because I talked about where the angle is outside the circle. There's two other places it could be. It could be inside the circle or it could be on the circle. I want to show a couple of examples of those real fast and how this formula changes when that takes place before we close here. Wait, come back. Don't leave me. Okay. And by the way, this same major and minor business, like I said, it can happen in any of the circumstances. It can happen with two tangents like this, like we showed. It can happen with a tangent and a secant, or it can happen with two secants. The rule stays the same, that you get the difference of the two arcs that are captured and then take half. As long as the point is outside the circle, that's the way the rule goes. The angle points outside the circle, this is the rule you use. Now, if it's on the circle, okay, if the intersection between a tangent and a secant like this is on the circle, what you're going to see is that on each side you've got one arc capture. You got one here, you got one there. There is technically no major or minor in these cases because there's only one angle captured. So there is no this. Okay, if it's on the circle, it's just half of whatever you capture. So if this giant arc right here was, let's say, 250 degrees, all you're worried about is getting half of 250. How much, Brianna, how much would half of 250 be? Wait, that's 150. Which is 250 in half.
Oh, 175.
No, wait. Now you went too far. That's 350. Scott's got it. He's got it. 125 is what it would be.
Oh,
okay. And then here,
yeah.
let's complete this side. Let's complete this side. If this arc is 250, how much is this arc? Remember, these have to make 360 because it's the whole circle. So if this is 250, how much is this?
110.
110. Now give me half of this to get this arc. Get this angle.
Huh?
Now give me half of this to get that angle.
55.
55. Okay. And look, if it makes sense, it makes sense. This tangent line, Brianna, this tangent line is a straight line. A straight line is always 180 degrees. So look, these add up to 180. The full circle makes 360. So again, you see the interconnection. So that's the whole key there. All right, so that's when it's on the circle. So then there's only one other circumstance that we haven't touched upon. We've had the angle be on the circle. We've had it be outside the circle. Where's the only place the angle point hasn't been?
Completely outside?
No, wait, no, we did outside. We started with outside, and then we just put it on the circle.
Inside?
Inside the circle. So if the angle point now is inside the circle, watch what happens. Because I want to make sure we get this last one in. So now this is only, now inside the circle is only going to work with 2 secants. It can't work any other way. So okay, so here are the 2 arcs I want to focus on. I'm going to focus on these right here. I could do the same thing with the top and the bottom ones too, but I just want to demonstrate this for the purpose here. Okay, so here's those. Now, what if I told you this? Let's suppose that this arc captured was, let's say, 80 degrees. Let's say that this arc that I capture over here on the right side, let's say that this one is, let's say, 64 degrees. What I want to know is what the measurement of these 2 angles, I want to know what the measurement of what those 2 angles on the inside are. Yeah. So I want to know what the angles on the 2 insides are. Now, the first thing I want to stress is both of these angles are the same because they're on opposite sides of an X intersection. That makes them what are called vertical angles. So they have to be equal. Now, if you remember, when we were outside, recall that when we were outside the circle, the formula said half of the major minus the minor. That was when we were outside the circle. When we're inside the circle, what's this going to be instead of major minus minor?
Plus?
Got it. So let's add those. Total it. Give me half. No, wait. Ends in 2. Wait. Half of 14 is 72.
Oh.
There it is. Okay. So each of these angles then would be 72 degrees. Okay. So you get both of them, stuff like that. And again, here, let's just do one last one quick the other way around. Wait. What do you mean? What? Playing bridge? Wait. Okay, David, you're gonna have to explain that one. I don't know what you're getting at with that. Okay. So here, let's do this one with with going backward a little bit. Okay. So picture this then, Brianna. Oh, thank you. We get very thirsty.
It's Wendy's.
Okay, well, the reason why we say major and minor, David, again, is because of the fact, now in this circumstance, the terms major and minor really don't apply all that well. But previously, when we were talking about circles in earlier streams for my geometry guys, we talked about that in any circle, if you have an angle, if you have an arc going from here to here, if it's less than 180 degrees, we call it a minor arc. And the one going the long way around that's greater than 180 degrees, you call a major arc.
What happens if both of them are 180?
That's the terminology here and stuff like that. Really, you guys are trying to learn bridge? God, you like the weird games, Scott or whatever, or you like the real thinking games. You like bridge, you like mahjong, all those kind of stuff. Yeah, that's how it works, David. That's the whole concept there. Yeah, technically, major and minor, don't really apply here in the same strict way because of the fact that it's usually there's a fair chance that neither one of the two arcs is going to be over 180 degrees. So just for the purpose of differentiating between the two, we're just in theory calling the major the bigger of the two arcs and the minor the smaller of the two arcs. Just for the so that's the thing. Oh yeah, go and shogi. Yeah, that's right. I forgot. You like those too. So here, let's try 51 degrees on both ends. Okay. If I then told you that that this arc over here was, let's say, 48 degrees, what I want to know, actually, here, let me make it, okay, let's make it 38 degrees. I'm sorry. Then the question is, how much is this arc over here that gets captured? All right. So here, let's rewind. Let's rewind the problem here. Okay. So you got 51 as the end. Okay. So work your way backwards then. Go backward. Well, well, it's always lagging to a point.
102.
Okay, so you get 102 there. So now the sum of those, so you've got, now you don't know which one this is, so let's just, so solve with those, and how much do we get for, the measurement of, well, what operation are you going to do with those two?
Subtract.
Yeah, okay, so do one, all right, so go ahead. 102 minus 38, go for it. You guys got it there? I see. Why did you do that? It's going to be 10, okay? And that's pretty much it. So, yeah. So I figured my guys are going to be seeing these in the next week or two and stuff like that. I figure let me leave that there so that they can sneak a peek at it later. So I figured my guys are going to be seeing these in the next week or two and stuff like that. I figure let me leave that there so that they can sneak a peek at it later, so that if they have any more questions, they can watch you do it and explain it. And my good friends, thank you for joining us, my friends, to help out with this and stuff. So now they can see this and be able to try to work forward and backward and get everything that they have to get out of this. And I hope you guys got a lot out of this and stuff or whatever. All right. So anyway, so as I said at the top, I'll just mention this one more time. So like I said, tomorrow when we come back here for our final live stream for this series, okay, what we're ultimately going to do is, like I said, we're going to close this out. We're going to have a whole fun and games bash here that we're going to be doing here. So all the games that we were playing here and there on previous Fridays and occasionally on some other days, we're going to bring them all back. We're going to do them all again. So we're going to do give and take. We're going to do the probability standpoint. Okay, so we'll do all those. So we're going to bring them all out. We encourage you guys, please join us at 2:00 on Friday and come play the games with us, because we'd like to play along with you guys and just have some fun, mess around. It's a good way before we have the unofficial kickoff to the summer to just kick back and relax. And as we've been doing tomorrow at 2 p.m. Eastern to have our fun with that. Tell your friends, come join us, come play. Let's have a lot of good fun and competition. For now, I'm Brian. She's Brianna. We will see you tomorrow here right on the channel. Take care. So long.
Bye.
Have a good one.
You're allowed to